Hey guys, so we're back. Today we're going to be looking at special right triangles, and the big start of it is going to be kind of just practicing that Pythagorean theorem again. And you guys have gotten this down. We've been practicing it most of the week, so I want to just kind of start us off nice and simple and get these done. Apparently I didn't give myself a lot of room to work on this one, so we'll just kind of go with this as a 7 squared plus x squared equals the square root of 257 squared. So as soon as we do that, we know that those cross out. So we're left with 49 plus x squared equals 257. Take 49 away from both sides, and you get x squared equals 208. Find that square root, that common denominator, and I came up with it would be x equals 8 square root of 13. And that'd be kind of your first way to go about solving that one. Next one's a lot more simpler because we don't start with a radical right away, but we are going to end with a radical. So we're going to take that 10 squared plus 11 squared equals x squared. And we get 100 plus 121 equals x squared. 221 equals x squared. Take the square root of x on both sides. Take the square root, of both sides. We're left with square root 221 equals x. And that's your final answer there. All right, so when you guys start looking today, we have these two special theorems. All right, so these two special theorems are basically going to be how we can solve these problems. So what we have to do is we have to be able to identify basically how these problems would be solved. So when we look at a 45, 45, 90 triangle, right, it's a special right triangle in the sense that it's a isosceles right triangle. But when we look at it, we need to know that the hypotenuse is actually equal to the square root of 2 times x. Or if they give us the hypotenuse as 9, it's really square root of 2 times something that gives us that 9. And it's what you'd have to figure out. So when we look at this, we kind of look at this as a simple way to do this, and that's how we kind of do it. When we look at a 30, 60, 90 right triangle, this is a scalene right triangle, but it's not that special because of that part. It's more special because of the angle relationships. The hypotenuse is twice as long as the shorter leg, so it's always going to be 2x with your shorter leg starting as x, and the hypotenuse is going to be the square root of 3 times as long as the short leg as well. Now, this kind of doesn't make a lot of sense, so I wanted to kind of put it into a form that we might understand a little bit better. The legs in a 45, 45, 90 degree triangle will be congruent, and that's an important thing to remember. The hypotenuse, the leg length, is times the square root of 2, right? So basically when we look at this, we'll be looking at, if we have these two legs to find the hypotenuse, it's going to be 3 times the square root of 2. And that's how we would solve this out. So when you go to solve this, right, it's pretty simple for us to see and solve. Just multiplying there, 3 times the square root of 2. And that's your final answer here. So it's not too difficult to do a 45, 45, 90 when you're given both legs. Now let's talk about a 30, 60, 90 special right triangle. When we talk about a 30, 60, 90 special right triangle, the square root is 3 times the hypotenuse divided by 2, and that will give you the longer leg. The hypotenuse is divided by 2, and will give you the shorter leg, and the hypotenuse is simply x, or 2 times the shorter leg, depending on how you look at it. So the ratio here would be 1, as our 30-degree angle is going to be the shortest side. The middle side is going to be the square root of 3, which is going to be less than 1, so you guys know, or less than 2, excuse me. So it's going to be smaller than 2. And then the last side, the 90-degree side, our longest side, is going to be the shorter side times 2. An example would be the one on the left here. The longer leg is the one on the right, sorry. The longer leg is the square root of 3 times the shorter leg. So if we know the shorter leg is 5, right? We know that the longer leg is 5. We know that the shorter leg is going to be square root of 3 times s. And when we go through and we do our math, we divide each side by the square root of 3. And we're left with 5 over the square root of 3 equals s. We don't want a fraction with that on there, so we're going to multiply both the top and bottom by the square root of 3. And that's going to give us 5 square root of 3 over 3 equals s. And when we keep working with this one, the length of the hypotenuse is going to be 2 times the shorter leg. So we're going to take that 2 times 5 over the square root of 3, or 2 times 5 times the square root of 3 over 3. And when we do that, we'll come up with 10 over 3. 10 square root of 3 over 3. And that would be your answer there as we kind of start to figure that out as our hypotenuse. Now, let's take a look at a couple of them. Let's make sure that we can get this kind of down. So we know that this side's automatically going to be 4 as well, right? Because it's a 45, 45, 90 triangle. It's a special right triangle in that sense. So when we look at that special right triangle with that, we know that x, which is going to be our hypotenuse, we know that it's going to be take the shorter legs and times it by square root of 2. So 4 square root of 2 is going to be your answer there. Not a lot of math for you to do on that one, right? And especially because it's kind of already there. Right? When we look at a 30, 60, 91, it's a little bit different for us, and we're going to have to maybe do a little bit more here. They give us these first things, right? And when we look at our ratios that we just went over, we know that the shorter leg is a ratio of 1 and the hypotenuse is a ratio of 2. So what we can automatically do is decide that A equals 2 because we know now that it's going to be half of the hypotenuse. Now, where it gets longer is the one that's opposite the 60-degree angle. When we have one that's opposite the 60-degree angle, it's going to be the square root of 3. So what we have to do is we have to go square root of 3, all right, times 4, oopsie, over 2. So what we have left here is we have 4 square root of 3 over 2, which we can simplify down to that, just simply that. And that's kind of there, and we are all set to go. That's what it is, all right? So with that, I'd like to thank you guys for watching today. Tomorrow we'll take a look at story problems using right triangles and triangles in general. And make sure that we have this down this week on our #Algebra Friday. Thanks for watching. Take care.